Hello, Richard here, and welcome to part 4 of fixing the saddle on the Mini Lathe. Bit of a saga this one, isn't it? If you've been following along so far, you'll see we've encountered various problems along the way, as you'd expect with these sorts of things. In the previous instalment, I determined that the bed was actually bent, that the bed would go along flat to this point and then it would just go up like a ski jump. So that's what we're going to talk about this time round and look at how we're going to actually sort out the bend in the bed. Right, hopefully you've got a decent view of the lathe bed there. As you can see, as I say, the saddle binds up around here. And what I found is that if I loosen off the rear gibs, so I can do that now. So if we loosen the rear gibs off quite a bit, what you can see now is it slides quite happily. It'll slide the full length. And the front gib is really quite tight. There's very little play in that. Well, actually no play I can feel if I try and wobble that. So the front gib is solid. And here's where we've got to start making some assumptions, because I don't have the tools to do a sort of thorough analysis of the geometry of the bed and all that, so I've got to make do with what I've got. So it means I do have to make a few assumptions here and there. Given that the front of the way, the V, is okay, I would assume that it's quite straight and flat. So that's one assumption. Now, I did check that with the straight edge. Take the saddle off, if it come off the end. No, I need to loosen it a bit more because there's a bit of a problem at that end. So let's just loosen the front one off as well, so we can get this out of the way. There we go. Right. So checking this front way, checking the top surface here, this checks out quite flat. There's a little bit of daylight under here, but the top of this isn't a bearing surface anyway. The underneath of the way, this does check out to being quite flat as well. I've checked that. I've run a gauge over it. That seems quite good. Now, what I'm going to do, I'm just going to flip the lathe over and show you what the state of play is on this rear way, because I think this is where the problem is. So we'll do that and I'll bring you back in. So this is the rear way. The top surface here, where the saddle runs on, that has to be flat and straight. So does the underside. The underside is where the gib runs. So both sides of this need to be flat. Like I said, in part 1, I did measure this with a micrometer, and it seemed to be within about 0.06 of a millimetre, 2.4 thou of variation over about this distance. I measured over this distance, and I remember doing that. I called this sort of left, middle, and right here. I didn't measure any further than this, just because logically, this is where the tailstock sits, and the saddle will never get this far. So I didn't bother. So I thought all I saw was 8.44 up to about 8.50. Didn't sound like much, but it's funny. You can see here I've drawn some points and I've written some dimensions. And here we start at 8.44 millimetres, 8.44 millimetres, 8.44, 8.44, and then we go 8.45, 8.46. So it's flat here along to this point, and then it starts to taper up. And it goes up to 8.5. And if you go all the way to the end, you end up at 8.57. This is where it binds. So quite clearly that looks like this is getting thicker and binding up the gibs. From 8.44 up to 8.57, that gives us 0.13 millimetres of difference, which is about 5/1000th of an inch over that whole distance, which is, when you measure it over the whole thing, you can see how bad it actually is. So that's what I believe the next problem is. And I need to work out, A, if I'm actually going to overcome that, and B, if I do, how on earth am I going to overcome it? Like I say, I've got limited tools at my disposal, so, I'm limited on what I can actually do. Now, what was weird with this was the fact that this is so flat along this length. At first, I thought I'd been sold a second-hand bed, because this looks more like a wear pattern. If you imagine that this once was 8.57 all the way along, and if the lathe's used, it's going to get most of the wear here up near the chuck, and I thought it had worn down. And I was quite annoyed to think that I'd been sold, a worn-out bed that had just been sort of repainted and sold on. But let me bring you back up to the top. Now, I don't know how well you can see this on the video, but if we look at the top of the bed where any wear would have taken place, you can see here it's still got the original grinding marks where this was surface ground. You can see the original grinding marks on this area where the bed doesn't actually touch. And where the bed would sit, where it would rest, there's no step. So there's no real wear. So it looks like the thing was actually just made wrong. So what we basically got is the bed is flat along here, and then it starts to kick up here. So if you imagine the design of a Russian aircraft carrier, you could get your planes on here and then they could basically take off up there because it's going to give them a bit of a ski jump. Checking with the straight edge under the back here, the undersurface here looks to be really dead straight, as dead straight as I can measure. As you saw earlier, if we put the straight edge on the top, like so, you could see that we had daylight showing under here. So there's definitely a bow in the top. So I'm happy to call the underside straight. And that means that all the error is just in the top here. What I can do is I can sort of verify that to an extent with the dial gauge. So I'm going to get a dial gauge set up on here, and I'll show you a few sort of measurements we can do with that. Right, what I've got set up now, I've got the dial gauge on the saddle near the back. The front gib is tight, and the rear gib has been loosened off a little bit. And what that means I can do is I can basically put pressure on the front here. If I push down on the front will be riding on the V, and the rear will be riding on the underneath surface, because by pulling it back, I'm lifting this off the top. So there's no contact here on the top, and it's just going to follow the way underneath. That's going to give us an idea of how level or not level the top surface is. That's the theory. So pulling back, we've got this on about 0 at the moment. Hopefully you can see that. And what we'll do is we'll just sweep along. I'll try and do it as smoothly as I can. So we're all nice and flat here, all on 0, and then we get to this point and it starts to go uphill as we measured. And we go all the way to the end, 0.1 of a millimetre, and we end up at about 0.13 millimetres, which we'd expect. And that's measuring at the sort of the far end here of things. So what I'm going to do, we'll do it again, but we'll measure here and see. This will give us an idea of whether this is sort of flat, which I think it is, but we should get this going from sort of 0 to 0.13 if we measure it at this point. So let's reset that back, and we'll just move things back a little bit. Notice the gauge isn't perpendicular. That's not too much of a problem, because I'm just looking for a difference in measurement. I'm not looking for an actual absolute measurement here. So as long as it just shows us as a change, that's all I really care about at the moment. So we're on about 0, and we'll sweep along there, staying still, starting to slope. Up it goes, and it's a similar story. So we've got the same slope at sort of both ends of this. That's telling me again it's not worn. If it was worn, it would only happen on the side that got the wear. And then what we can do finally is we could actually check here as well, check on this side and see what that gives us. So let me see if I can just move things in for that. So we're on about 0 there. Moved a little bit then. That was me. And there you go. You've got the same sort of slope. So it's sloped over the whole sort of width here. Both sides of this are sloped up. And, well, we've got to decide what we're going to do about it. So, yeah, it's dilemma time. And what am I going to do? Got two options, really. One is to do nothing at all. Just put it all together, pretend nothing happened, just leave it, not use a lathe ever again. No, seriously. One is to not do anything at all, but put the saddle on and just accept I can only really use it in this area here. I can just use it near the chuck, which is where I do a lot of my work. I don't tend to work at this end. But I can guarantee if I do that and I say, well, okay, let's just use it at this end, the first thing I'll need to do is wind the saddle out of the way and it'll bind up and be horrible. The other option is to then lower this end of the bed by scraping it, funnily enough. Now, the problem I've got with that is I don't have the tools really to measure that. I don't have the tools to indicate it. What I would need really is like a nice 3-foot cast iron straight edge that I can then put blue on, and I can put it on the bed and indicate it and get an imprint off it and scrape it nice and flat. I don't have one of those. I have this, which is it's quite a nice straight edge. It is quite straight. It comes, as I say, it comes in at about within 5/10,000ths of an inch. 0.01 millimeters thereabouts on the surface plate. So that's quite straight, but it's not that great for this sort of thing. I obviously can't take an imprint with this, so that's not going to work. I don't think it'd be too hard to scrape this down. I think one of the benefits I've got is that I could actually get a micrometer and I could actually measure the thickness of the ways at the back. So that's a real benefit. As I'm scraping it down, I'll be able to actually measure how far down I am. And all I need to do is get this back edge scraped in. I mean, I would do the whole lot, but I only need to get it right on this back edge. But as I say, my problem is I don't really have the right tools to be able to take an imprint and to know that it's flat. But I do have a possible workaround for that. Bit of engineering at home, improvisation, if you like, which is kind of what this is about. You know, they say the channel is engineering at home. It's not engineering in a fully equipped machine shop. So a lot of what goes on here, the things I do, the projects I work on are improvisation. You know, it's a bit like battlefield mechanics. You've got to kind of come across a problem and solve it with limited tools sometimes. So I reckon there's a way we can do this. I reckon there's a way we can scrape this down. And the worst case, really, when you think about it, the worst case scenario is that I mess it up. And one of the beauties of getting a Chinese Mini Lathe from a company called Krenex on eBay is they come pre-messed up from the factory. So it saves me a job. Yeah, what's the worst that can happen? I mean, you know, by hand scraping something, you scrape it in so slowly, it's kind of hard to go too far. Well, you can, but, you know, it's quite controlled. So as long as I'm careful and I control what I'm doing, it should be pretty good. All I really want is for the saddle just to sort of run smoothly along here. As I say, I'm not looking for precision. I'm just looking for improvement. I just want this to be better than it was. I'm never going to be making jet engine parts and Swiss watches on this, so it doesn't matter whether it's hyper accurate. It just needs to be better than it was when I started out. So I do have a plan. It's not a very good plan. It's a plan nonetheless. What I'm going to do, I'm going to have a go at scraping this down, scraping this flat, because I don't have a straight edge to check this with. My surface plate's a 12-inch surface plate, which I can just about lift up. So what I'm going to do is I'm going to use that. I'm actually going to bring the surface plate to the job and use that to indicate for flatness. Sort of disclaimer up front, there's going to be a whole load of improvising going on here and using tools in completely the wrong way and ways they're not intended for. But like I said, this is engineering at home and I'll use whatever I've got. So if you're easily offended by misuse of tools, I'd recommend looking away now, and I'll tell you when it's safe to look back again. And we'll have a good crack at scraping this down and getting it flat. So we'll get set up and then we'll start scraping the bed down. Right, what I'm going to do, I'm just going to scrape this evenly. I'm going to start at this end. This is my no-go line here. So that line, this is a side of goodness and this is a sign of not goodness. So I'm going to start this side and I'm going to scrape along and do one pass in both directions, that way and that way. And then once I've done that, I'll move over a bit, do it again, move over, do it again, move over, and so on, step scraping it till I get to this end. And then we can take a measurement here and see where we are. And it's going to take a little while to do. So I'll show you the first few passes and then I'll probably do the rest off camera and we'll come back when we've got something to show you. So let's give it a go, see how we get on. Might put a bit of masking tape over this way. I'm conscious I'm tapping it with the scraper, so I don't want to risk dinging it, so I'll probably protect that on the next pass. Right, this is the state of play at the moment, and this has been one sort of full pass. When I say one full pass, a full pass being step scraping. So, in other words, we started here and we scraped this length on both this face and this face, and then I came in 25 millimeters or an inch, and then scraped again, came in another 25 millimeters, scraped again, 25 millimeters, scrape, rinse and repeat, so on. That way, we're kind of taking most of the meat off this end where it's highest. So this end got, say, 10 scrapes, and this end only got 1. I will say as well that bear in mind, in doing this, the only bearing surface out of all of this is the sort of end, probably 12 millimeters of this, half an inch or so. That's all that sort of actually rests on here. So we only really need to get this scraped 12 millimeters in from this edge along here. I've decided to scrape both sides though, so that I keep this pretty much sort of on a level. What I wouldn't want to do in sort of future years is have this one scraped down and this piece kicked up, because then if I wanted to put a surface gauge on here to indicate anything else, it'll be out of whack. So it's not necessary to do this, but it's just, I find it's more logical to bring the whole thing down together. So after one complete pass of step scraping, I thought you might be interested to see the scores on the doors on the other side. So I'll flip it over and I'll show you how it's measuring up. Right, so what I've done is I've basically run the micrometer back over these points. You can see the dots here where I've taken measurements before. The original measurements are in black, so hopefully there's no glare on that for you. So you can see that from here, 8.44 is what we're sort of considering level here. There we had 8.45, 8.46, 8.50, 8.53. That's millimeters thick of this. 8.54, 8.56, and 8.57. What I've done, I've remeasured it, and I've just written the sort of the decimal part on the masking tape on the blue bit. So you can see 8.46 hasn't changed. There's no change there. It only had a really mild scrape. 8.50, that hasn't changed. That's probably had 2 light passes, so there's no measurable change. 8.53 has come down to 8.51. 8.54 has come down to 8.51. And 8.56 and 8.57 have both come down to 8.52. So that's really good news. That's basically got this now so that the total error between what we consider the level point, the flat point, and the high end is only 0.08 of a millimeter instead of 0.13. And this is kind of leveling out as well. So the actual sort of taper is shallower. So we've got 0.52 there, 0.51, 0.5, and then it kind of goes steeply down here. So I guess the shape of the bed at the moment, exaggerated, would be it sort of comes along flat, steps up to here, and then sort of levels off a little bit like that. So we'll carry on scraping, but now what I'm going to probably do is scrape it more like in bigger. I'll probably scrape it in bigger steps. So I'll probably scrape this area, and then this area, and then this area, and then we'll see where we go from there. So that's going to sort of bring this one down, then this one, and this one. I'll bring you back in when I've got something more to show you. I've been doing a bit more work on the bed, giving it a few more goes of scraping, and I'm getting a few high spots here and there. And the danger is if I don't sort of get this indicated fairly soon, get it blued up and check it for flatness, then I could be introducing all kinds of humps and bumps and valleys and things that are going to cause problems later on. So really now's the time to get some blue on this and see how flat it is. I want to flatten it down sort of with reference to itself, so then I can continue just to level it down. I said earlier that I was going to do this by doing some pretty nasty kind of misuse and abuse of tools, by using a surface plate to take an imprint of this, which would have worked. That would have been okay. It would have done the job. It wouldn't have been very pretty. But I actually have a cunning plan to do this in a much more elegant way. So I'll show you what I got in mind, and that'll happen in the next part. So don't go away.